In this video, I'm going to walk you through 5 code patterns I see every day in production environments that quietly burn through $10,000 a month or more without anybody even noticing. These aren't novel edge cases either. These are common everyday patterns that your engineering team probably has in their code base right now, like a debug log that never got turned off, a metrics tag that seemed like a good idea at the time, or a really chatty API that's making a few more calls than it needs to. Individually, they seem like nothing at all, but at scale, these are actually the reason why your cloud bill keeps climbing out of control, even though your infrastructure team already did the obvious optimizations. So like I said, in this video, we're going to talk about all 5 of those code patterns, see what they look like in real code, and quantify what each one costs, and then how to find and fix them. If you're an engineer that's ever been asked, why is our cloud bill so high? This is the video for you and your team. To start, we'll talk about exactly what's happening and why these patterns are so dangerous. And I also think it's important to note that these aren't misconfigurations or bad architecture decisions. They're small, seemingly reasonable lines of code that just add up at scale. The developer has no visibility as to cost impact while they're writing code, and no linter or CI check or automated review will catch that either. These automated systems are meant to check if the code works, not how much they cost over time. None of these systems realize that this specific function is going to run 50 million times a day once it hits production, so that single harmless line of code generates terabytes worth of data. Traditional FinOps tools will show you the data log or AWS bill, but they can't trace the spend to the specific code pattern. And that's the gap. You know you're spending too much, but you don't know exactly why. Frugal calls these cost traps. They're specific, identifiable, fixable lines of code that cause disproportionate spend.
Hey, I'm Craig, CTO and co-founder at Frugal. Quick interruption before we dig into these traps. Right-sizing your instances, committing to savings plans, this stuff is great. You should do this, absolutely, but it's not enough on its own. Here's what's changing. As our applications become more cloud native, we're using more managed services. And now we're layering AI on top of that. Managed services have just a fundamentally different relationship to your wallet. You're no longer just paying to rent a server in the cloud. You're now paying by the token, or by the gigabyte, or by the API call. So your code is spending money directly. And it's incredibly easy to fall into what we call a cost trap. That's where your code works fine, but it's doing something wasteful or less efficient than it could, and you end up paying a lot more for the managed services that you use than you need to. So let's get back to it and take a look together at some of the cost trap patterns that we see most frequently out there.
So the first cost trap we'll talk about is high cardinality metrics exploding your cloud bill. And what that looks like is adding a seemingly safe tag or metric to a really high traffic endpoint that becomes remarkably expensive over time. So every unique combination of values creates a new time series. And Datadog, for example, charges 1-to-1 on custom values. So cardinality equates directly to cost. So to look at this in production, something as simple as a user ID tag on a really high traffic endpoint, let's say you have 500,000 active users, that's 500,000 custom metrics build. And we've seen companies where a single high cardinality tag was responsible for over 40% of their Datadog build. So to fix this, Frugal detects high cardinality tags automatically by analyzing your instrumentation code alongside your Datadog usage. And we can replace high cardinality tags with bucketed or aggregate values like user cohorts or status codes rather than full response bot. That one fix alone could have massive impact, decreasing your cloud costs. The next one I want to talk about is one we're all guilty of, and that's chatty API calls. Essentially making a call to a metered service way more times than the task actually requires. This usually happens because nobody checks to see if the data was already available or if it could be brought in one batch rather than a lot. And a great example of this is, let's say you have a background job that processes incoming orders. Okay, so for every order, it makes a call to an external tax calculation API to get the sales tax rate for that specific zip code. Let's say you have 50,000 jobs a day, but the tax rate for any given zip code changes almost never. You're making 50,000 API calls to get the same handful of values you could have cached locally. So let's say conservatively, you only needed 100 of those calls. 49,900 API calls daily return data you already have. So in that instance, you're paying for the API call, the Lambda execution, the time waiting for the response, data transfer, all for information you already had that hasn't changed since yesterday. So let's do the math quickly for our tax calculator example. 50,000 calls a day is 1.5 million calls a month. Even at 0.002 cents per call, that's $3,000 a month on one API alone. Plus the compute costs of 1.5 million Lambda invocations, and they're sitting idle waiting for a response. A local cache with 24-hour time to live reduces this to under 500 calls a month, conservatively. Frugal fixes this by caching data that doesn't change frequently or checking the API docs to see if these calls support batching, where they often do. They identify these patterns by analyzing call frequency relative to how often the data actually changes and implementing fixes by batching, saving you a ton. I alluded to this off the top, where a lot of these cost traps actually are a direct result of good practice rather than poor architecture, and this is what I had in mind. The third cost trap is debug level logging left on in production. This can happen really easily. How we've seen it happen before is your team adopts structured logging, which is great practice. Your template has the standard fields like your timestamp, your log level, all that. But somebody needs to debug an auth issue, for example. So they attach a request context tag that never gets turned off. So all of a sudden, every single log message across the service carries an extra, let's say 1.5 kilobytes of context that nobody needs and nobody reads. The log message itself might say order processed successfully, but the attached context field is just huge amounts of dead weight. Now, this one's sneaky because you don't see the problem in the console. The log message looks fine. You only notice the problem if you're looking at the entire payload size. Doing some quick math on the cost impact of debug logs being left on, let's say one service emits 10 million log messages a day with 1.5 kilobytes each of extra context. That's 15 gigabytes of extra log data per month from that one service. Let's say you have 20 services. That's 300 gigabytes of bloat every month. Given that you're paying per gigabyte, 300 gigabytes of data you don't even read is massive waste. So to fix this, you need to audit your structured log templates. You need to ask for every field, does anybody even query this? And if the answer is no, it doesn't belong in your log message. So the same applies to OAuth scopes for session objects or the raw request headers. These belong in trans space or a dedicated debug context, not stamped to every info message. Frugal detects bloated log templates by comparing the size of the context field against the actual message and flagging templates where the context outweighs the message by 3 times or more. So the fourth cost trap is inefficient database queries. It's really similar to the last one where your debug logs are being left on in production. However, it's different fundamentally where your structured log template is bloated out of the box. Whether you're attaching full auth scopes or some other fields you don't need, the cost implications are just as massive as the previous cost. Frugal's found instances where large repetitive files in a log template were responsible for the majority of a team's logging build. The solution to this is to move large contextual files to trace bands or specific debug context rather than embedding it in every single log line. Frugal can detect bloated log templates by comparing field sizes across messages and flagging repeated large payloads that drive disproportionate costs. The last cost trap is the busted AI prompt cache. And this is the sneakiest one on the whole list because there's no error, there's no degradation in quality, there's no alarm, there's just a more expensive bill. So how this works in practice is your team will set up a cache for your system prompt, and the idea is to save you on input tokens. Let's say you have a large static system prompt at 2,000 tokens. That gets cached, and every API call to your AI provider can reuse that cache at a discount. What happens though is that any changes to that system prompt or your tool definitions invalidates the cache. So something as simple as moving a dynamic variable from the bottom of your prompt to the top means that any cost saving measures you've put into place are now invalid. If caching was saving you $2,000 a month, that silent break evaporates that savings. You're now paying $2,000 a month more and nothing in your monitoring will tell you because everything seems to be working fine. Frugal can fix this by detecting cache hit rate drops and correlating the API usage with recent code changes to find the specific commit that broke the cache. Then it can restructure the prompt and restore the cache, restoring your savings. Those are the 5 cost traps Frugal addresses. All of those look completely reasonable on review, but all of those can also cost you 10 grand a month or more at scale. The problem is that traditional FinOps only shows you your bill going up. They can't show you the patterns that are causing it to do so. That is the gap Frugal was built to close. Frugal traces your cloud spend down to the code driving it. It finds these cost traps automatically, generates Frugal fixes with the code to fix it, and quantified cost savings estimates. There's no dashboards to interpret, no homework for your team. It just works. If you want to see which of these 5 code traps are in your code right now, click the link in the description to book a free demo call with our team. It takes about 30 minutes and we'll find the exact spot in your code with a specific dollar savings estimate attached. Also, if this was useful, hit subscribe because we'll be breaking down specific cost traps like these every week. We'll see you next time.